Okay, number 7 here has a ball dropping onto an incline. We're given a speed, given a coefficient of restitution, and we want to find the speed of the ball after it bounces off the incline. Okay, I'm going to start by redrawing my velocity vector right before. Okay, so here's my incline, and we have perpendicular to that. This is our, 20 degrees. Okay, and the ball's going to bounce back afterwards, obviously. Something, thought I had a different color, something like this. Okay, so we want to find that velocity vector. If this angle is tilted up 20, this perpendicular to the incline is 20 off of vertical. So we know that's 20. We don't know this angle, theta. We don't really need to find it. What we're really looking for is, it's hard to draw, this component along the incline and this component perpendicular to the incline. Alright, we set up these sorts of problems by defining the plane of contact. Okay, in this case that's the incline, and then perpendicular to that, line of impact. We'll call this one y and this one x, and we'll take x and y like positive like that. Okay, so along the plane of contact it's easy. Along the plane of contact, the x direction, the velocity in the x direction afterwards is equal to the velocity in the x direction beforehand. Alright, so if we look at the components of this vector, I'll draw them down here. Okay, so this vector and that vector are equal. And that's equal to, let's see, we had 7 meters per second. Okay, so it's 7 times the sine of 20. Alright, so that gives us the x component afterwards along the line of impact. We have to apply our coefficient restitution equation, and that said the x prime of the ball minus, I'll write it down here, the x prime of the earth was equal to Vx of the ball minus Vx of the earth. And it makes it a little bit easier. Those are negligible. Alright, so solving this equation gives us Vxb prime is equal to negative EVxb, which is minus 0.7. That's our value for E. And this component, let's see, I used a bunch of wrong variables here. So sorry about that. That should be Y. We're looking along the line of impact here. All these should be Y's. And that should be Y. Okay, and this should be Y. This component is negative, and it's the cosine. So 7 minus 7 cosine 20. Okay, I'll finish working it up, symbolically, then plug in the numbers. Our final velocity of the ball is going to be Vy prime squared plus Vx prime squared. I'll take those two numbers and combine them to get the final velocity of the ball. Okay, so here's my calculator. I'm going to calculate this number first. I'm just going to call x equals 7 sine 20. I have to put my multiplication sign in there. It gives me a value of 2.39. So I'll go ahead and note that here. Okay. And come on back here. We'll do a y equals, my negative signs will drop out. I'll just have 0.7 times 7 times cosine 20. Okay, that'll give me 4.6. So this is going to be square root. I'll keep the numbers in the calculator. 2.39. Just to be same that I wrote it here, 4.6 squared plus 2.39 squared. And that is a square root. .19 units of meters per second. Okay. Just to review, we had to identify our line of impact, plane of contact. Plane of contact, velocity component stayed the same. Line of impact, we applied our equation for E. Conservation of momentum was not used here because we had the Earth is not moving. So we weren't able to use that, but we were able to use our coefficient restitution equation.